We will wait for just 2 minutes.
Okay, ma'am. Okay.
Hello everyone. It's already 7:03. We will start our class. I am Anu, pursuing PhD from University of Hyderabad. Hello. So today I am thinking we will discuss regarding group theory, molecular symmetry and group theory. 2 questions I have taken from different years, and then while solving that we will learn some basics of group theory, point groups basically. Character table and all will not be considered in this class. The questions whichever I am doing and the basic concepts related to that will be taught today in today's class. Okay. So I'll start sharing the presentation. PPT is visible.
Yes, ma'am.
Okay, fine. So the first question we are going to discuss is from GATE Chemistry 2015, question number 51. The point group of IF7 is. 4 options are given to us. So in order to find out the point group, before that we have to find out what is the structure of the particular molecule given, and from the structure we can find out the symmetry operations and symmetry elements associated with the molecule, and then it will give us the point group associated with it. So first of all, in order to understand the shape or geometry of the molecule, we should know valence shell electron pair repulsion theory, from which we can find out the shape. So this is a simple theory which tells that atoms consist of electrons and the charge will repel each other and they will try to stay as far as possible. So this is the basis of valence shell theory. For example, if we have 3 atoms, one central atom and 2 other atoms, the 2 will try to stay as far as possible, meaning at 180 degree to each other. So the shape will be linear. Based on this theory, we can find out first the shape of IF7. So how we will find out? For that, we need to find out the total number of electron pairs or total number of electrons. In IF7, the central atom is iodine and it has 7 valence electrons. And the side atoms are fluorine, and how many electrons each fluorine require is 1 in order to complete its octet. So totally 7 fluorine atoms are there, and therefore the total number of electrons on IF7 will be 7 plus 7 equal to 14. Therefore the total electron pairs will be 7. And based on the number of electron pairs, as we saw earlier, we can find out the geometry of particular molecule given. And the geometry in this case, since we have 7 electron pairs, the geometry will be pentagonal bipyramidal, and there is no lone pair, and the shape will also be pentagonal bipyramidal with iodine as central atom, and 5 fluorine will be in pentagonal planar, and 1 in axial up and 1 in axial down, 2 fluorine atom in axial positions. Okay, now we know the shape of IF7. So from the shape, we need to find out the point group. So before finding out point group, we will find out, first of all, we will learn what is symmetry operation, symmetrical element and all. Okay. Any object is said to have symmetry if it can take up more than two spatial orientation that are indistinguishable from each other. So a symmetry operation means is any action when we are performing on a particular molecule will give an orientation that is indistinguishable from the original one, and the point, plane or axis along which we are performing the symmetry operation is called as symmetry elements. So for us, there are 5 basic symmetry operations or 5 basic symmetry elements. We should know what is this in order to find out the point group of each molecule. So if anywhere you guys are not clear, you should stop me in between and ask. Okay. So the first operation is identity operation. This is very simple. In this, actually, we are doing nothing to the particular molecule. It's also said as we are rotating it by 360 degree. That means, in effect, we are doing nothing or leaving the system alone. So this operation and the element associated with it, which is represented as E, identity element, all molecules have identity element. So why such a operation is required means it is useful in application of group theory mathematically. That will come in later parts. So this is one basic operation that all molecule has. So there is nothing complicated in this. Now the next operation is proper rotation operation, and the element associated with this rotation axis. So in this case, we will rotate a molecule at a particular axis to get an equivalent configuration. So if we are rotating a molecule at 180 degree, then the n will be 360 divided by 180 equal to 2. Then it is said to have a C2 rotation axis. For example, in case of water, we know water is having a bend shape. So if we draw an C2 axis, like an axis, consider along oxygen atom, and if we rotate it by 180 degree. So what will happen? This A will come here and HB will come here. Both hydrogen atoms are same. This is just labeled so that we can understand how rotation is happening. Okay. So we are rotating the water molecule along the x-axis along oxygen. So we are getting an indistinguishable same structure. So in this case, water is said to have a C2 rotation axis. Another example is BF3. So BF3, what is its structure? Consider this in all one B and all F atom in one plane. And imagine a C3 axis passing through the x-axis through the boron atom. So if we rotate it by 120 degree, this fluorine will come here, this will come here, and this will come here. That means ineffectively it is same. So we are getting an indistinguishable structure by rotating it by 120 degree. So it is told to have a C3 rotation axis. Similarly, if we consider along BF one axis, and if we are holding along BF and rotating it, that means what will happen? This BF will remain same, but this fluorine atoms will interchange with each other. So in this case also, we are getting an indistinguishable configuration. So this have one C3, C2. C2 will be along each BF. 1 BF, 2 BF, 3 BF. Along each BF, we will have a C2 axis. So this has one C3 axis and 3 C2 axis. So the highest fold rotation axis, in this case, which is C3, is called as the principal axis, and the other axes are called as secondary axis. Okay, this is second symmetry operation. Now, going for a third symmetry operation, that is reflection operation. And the symmetry element associated with it is called as plane of symmetry and is represented by sigma. If in a molecule, it has a plane that divides the molecule into two halves such that one is exact mirror image of other. For example, if we take water itself, if we cut along the oxygen, so this side is exactly the mirror image of this side. So this has a sigma axis. Similarly, if we cut along the plane, along oxygen, hydrogen, hydrogen. So in this case also, it has an exact mirror image, and we can say in such molecule, sigma is present. So, and sigma can be divided into three types: sigma B, sigma H, and sigma D. Sigma B means vertical mirror plane. Like here, in case of water, this is the principal axis, C2. Only one axis is there, C2. So along the C2, we have a sigma, right? We saw here. So if such a sigma exists, it is called as sigma V. And if a sigma exists which is perpendicular to the principal axis, it is called as sigma H. So that is called horizontal plane of symmetry. So if we consider BF3, C3 is the principal axis, it is along boron. So if we consider a plane along the BF3, like the plane where B and 3F atoms present, along that if we consider and if we cut, so what will happen? We have a sigma H, which is perpendicular to the principal axis. So when a sigma is present perpendicular to principal axis, it is called as sigma H. And another kind of sigma exists, which is known as dihedral plane of symmetry, when a plane that contains principal axis also bisects two similar C2 axes. So it is present in alene kind of molecules. If you are not clear, you can ask me, because this is important, and based on we should know to find out which symmetry elements are present in which molecule. Otherwise, we cannot find the point group of each molecule. Okay. Now, let us move on to the fourth operation, the inversion operation or center of symmetry. If a straight line from any atom is projected through the center of molecule, encounters at equidistant and equivalent atom. If we see, for example, we can start from PtCl4 2-. What does the definition state? If a straight line from any atom, let us consider chlorine, is projected through the center of molecule. Here the center is platinum. We are projecting it through the center of the molecule. Encounters an equivalent atom, means it should encounter chlorine, another chlorine at equidistant from the center. It is encountering another chlorine. So if such a symmetry operation exists, then we call it as inversion center, and such molecules has center of symmetry. CO2 also, if we start from this oxygen, move through the center of molecule, and we will meet another oxygen at equidistant. So CO2, N2, all these molecules is having the inversion operation. And the last operation is called as improper rotation or rotoreflection operation. So in this case, what we do is that we will rotate at a particular angle, and then we will keep a plane perpendicular to that axis, and then we should get an equivalent configuration. If such an axis exists, it is called as improper rotation axis. So in BF3, we are keeping a C3. What will happen when we keep it C3? So let us name this A, B, C, just for identification. If I am keeping C3, each fluorine will interchange, right? So B, this will come FA, this will come FB, and this will be FC, right? This is in first we keep a C3 axis. Now what it is telling? Followed by a reflection plane perpendicular to the axis. So perpendicular means like this. So like this we are keeping a plane. That means it is passing through the middle of each boron and fluorine atoms. Consider like that. So it has exact mirror image and exact equivalent configuration. It doesn't change at all. So if such an axis exists, it is called as improper rotation axis represented by an Sn. Here n will be 3 because it is first rotated along C3 axis. Similar exists in case of ethane also. Okay, these are the 5 symmetry operations and the symmetry elements associated with that. Okay, if I ask you NH3, what is the rotation axis present in this molecule?
C3.
Huh?
C3.
I can't listen to you.
C3.
Hello?
Hello, C3 axis.
C3 axis. Yeah, correct. C3 axis. So I hope you guys can understood what I am meaning to tell. Then if these points are clear, inversion operation, improper rotation axis, if this operation and the symmetry elements are clear, then we can move on to the next answering the question. So for that, we need to find out the point group. In the question, point group of IF7 is asked. So there is a simple method. There can be either a special group. Special group means it can be either linear, tetrahedral or octahedral. So this is easy to understand. From the shape itself, we can identify whether it is linear, tetrahedral or octahedral. So if it is not a special group, then how we will find out which point group it present to? So first of all, the question we should ask is that whether Cn is present or not. If the answer is no, first, then we have to ask sigma present. If sigma is present, the point group is Cs. If only inversion center is present, point group is Ci. If no sigma or no I is present, that means only identity element is present. In such case, it will become C1. Okay, this is easy. Now, if Cn is present, then we have to ask whether it is a consequence of S2n. This is actually very rare case. S2n group is very rare case. Only in like S6, S3, etc. are present in very rare molecules. S6 is present in hexaminobenzene, and then I think S4 is present in tetrabromopentane and all. So it is very rare case, and they won't ask in mostly from this point group, questions are not asked. Okay, so in this case only we will find a Cn axis and an I. Okay, mostly. Then in this case, if we are going through this case, then we have to, after this question, the question we should ask is whether NC2 axis perpendicular to Cn is present or not. Like in case of PF3, it had one C3 and 3C2. Right. So a Cn axis is present, and perpendicular to that we had NC2 axis, means 3C2 axis. So in such case, we have to ask that whether such is present or not. In such case, if moves to yes, then it will be under D. The first letter of the point group will be D. If it is not, the first letter of point group will be C. Okay, like in water, it does not have NC2 axis perpendicular to the principal axis and all. So in such case, the point group start with C, and if it has, in like in BF3, the point group start with D. Now for the remaining part, we have to just see whether sigma is present or not. If present, but whether it is sigma H or sigma D. Based on that, we can find out whether it is DNH, DND, DN, etc. Okay. So now in case of IF7, we have pentagonal bipyramidal as the geometry. So what is the first question we should ask? Whether it has Cn present or not. Whether Cn is present or not, can you tell?
Yes, ma'am, it's present.
Okay, it is present. And what n will be what in this case?
5.
5, correct. So in this, through this, if we keep an axis and if we rotate, then we will get an equivalent configuration. So we have a C5 axis present. Okay, now the next question we should ask is that whether n perpendicular C2 is present or not. So in this case, C5 is along the x-axis. So along y-axis or z-axis, if we have C2 or not. Yes, in this case, we have C2. How? If we hold a C2 through this, then this will interchange with this fluorine. This fluorine will interchange with this, and this both will interchange with each other. Okay, like 1C2. Similarly, 2C2, 3, 4, 5. Similarly, we will have 5C2 present, which are perpendicular to Cn. So, the first letter is D. Okay, now the next question is sigma is present or not. Sigma is present or not, how we will see? If sigma h is present, it will be dnh, sigma d, or based on that. So in this case, this is the principal axis along x-axis. So we have to find whether sigma present along x-axis, y-axis, or so on. X-axis we don't have. Y-axis we have. Y-axis, if we cut through this I and 5F, this 5F and this F will be acting as a mirror image of each other, and we are cutting through all these 5 fluorine and 1 iodine. So it is perpendicular to the principal axis, and we have a sigma h. In that case, we tell if it is perpendicular to the principal axis, we tell such a molecule has sigma h. So if sigma h is present, then we will have D5H. The first one we should check is sigma h. If sigma h is not present, then we have to check for sigma d, and if both are not present, then it will be simply a Dn. If sigma d present, if sigma d present, it will be dnd, and first question is sigma h. So it will be dnh. In this case, sigma h is present, so it will be dnh, and in this case, n is 5. So the point group will be D5H. So the correct answer to the question is option B, D5H. Is this clear?
Yes, ma'am.
Okay, fine. Now similarly, we have to find out the point group of CH2 double bond C double bond CH2. So in this also, this is just a classification. We can classify molecules based on low symmetry, high symmetry, or special symmetry. This we already discussed earlier in a different form, in a flowchart method. This is in a table kind of form where we can find out which group, which symmetry element is present in which group. Okay, so now if we want to solve the question, first of all, we can imagine CH2 double bond C double bond CH2 inside a cube. Otherwise, it will be difficult for us to find out, to see the C2 axis present inside. So we can imagine it inside a cube. Okay. So inside a cube, CHA, I am just labeling different hydrogen atom in different name, like HA, HB, HC, and HD. Okay. If we rotate it by 180 degree, what will happen? This HA will move here, HB will come here, right? And HC will move here, HD will come here. So we are getting an indistinguishable configuration. So this has a C2. This is clear? Because it is a little difficult to see. So that's why I'm asking, is this one clear?
Yes, ma'am.
Okay, fine. So if you got one C2 along the x-axis, similarly, we can get one C2 along the y-axis and one C2 along the z-axis. Okay, so we have one C2 and NC2 means here 2C2 perpendicular to the C2 present. So the first question, Cn is present or not? Yes, C2 present. And the next question, whether NC2 axis perpendicular to Cn is present or not? Yes, 2C2 is present. So the first point group, first letter will be D. Okay, that much is clear. And N here is 2. Now we have to find whether H is present or not, sigma H or sigma D or no sigma is there. So we can, in order to find that out, let us see, this is allene, right? So we have to imagine this in allene, how the structure is. For one carbon atom, if both hydrogen is in one plane, and then for this carbon atom, one hydrogen will be out of plane and one hydrogen will be in to front. Okay, so I want you to imagine one plane in which we are passing through HB, HA, C, and C. If we are passing a plane through these atoms will remain in their position only, right? But this atom will interchange the positions. So this will become, so if we like pass a mirror plane along this, the HC and HD will interchange with each other. HC will go to back and HD will come to front. Okay, so in that case, we are getting same indistinguishable structure. So, and similarly, one more other plane we can pass, like we are passing through HC and HD, C. In that case, this both will interchange with each other. Okay, so like that, we can get 2 sigma. So, how to find out whether that is sigma D or sigma H or so on? We have is C2, C2 and C2, 3C2 we got, right? And this sigma D is actually in between 2C2 axis. So such a sigma plane is called as sigma D. So in this case, we have sigma D and the group is called as D2D. Okay. So the point group of allene will be option D, D2D. It is little difficult to understand, so we have to imagine it in a cube or imagine it in such a way that we have to imagine 2 hydrogen atoms are in a plane, one is out of plane and one is in plane. And then we have to cut the allene molecule so that we will both the plane which we are cutting, except that 2 hydrogen, that other 2 hydrogen are interchanging with each other. It is a little tricky to see, but from the option also, if we can see the first one D, 2, this much is clear. H or D is more difficult. Since we don't have a perpendicular to the, all axes are basically principal axis in this case because all are C2. And if we can't find, we can find that 3 C2 axes are there perpendicular to each other. And since the plane we are passing is in between C2, it will come to D2D. It is a little difficult. Can you imagine that? So I don't know how to explain this. If like if you have 2 hydrogen atoms like this in one carbon atom, then you have 2 hydrogen atom like this. So you can cut one plane like this, where you cut these 2 hydrogen atom and this both will be interchanging with each other. This is one plane. And one more plane is where you are cutting through this 2 hydrogen atom through like this. So in that case, these 2 hydrogen atom will interchange with each other and this 2 hydrogen atom you are cutting. Okay, so like that 2 sigma planes you will get. Is this clear?
Yes, ma'am.
Okay, fine. If it is clear, then we can move on to the next question. Okay, so based on this, we can find out point group of any molecule. For example, if we have okay, Br, Br, Br. Okay. So if we have such a molecule, then what will be the axis present? Principal axis?
C3.
C3. Yeah, correct. So we have a C3 axis present. Now, the next question is whether N perpendicular C2 axis present or not. Yes, we have. How? If we pass through a C2 here, this bromine and this bromine will interchange with each other. Similarly, one C2 axis here, these two bromine atoms will interchange with each other, and one C2 axis here. So we have three C2 perpendicular. So the first is D, and since Cn is 3, D 3. And the first question we have to ask is whether sigma H is present or not. The principal axis is in x-axis. So we have to find out along y or z whether any plane is present. So yes, it is present. If we cut the molecule along the y-axis, then it is an indistinguishable configuration and we have sigma H. So the point group will be D3H. Similarly, if we can have C, Cl, 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 H. Okay. So in this case, we have a C3 axis, right? If we consider an axis through here, then each Cl will interchange with each other. So if we rotate by 120 degree, each Cl will interchange with each other, and hence this have an C3 axis. Whether perpendicular C2 axis is present or not? No, it does not have perpendicular C2 axis. So the first point group, first letter will be C, and since the principal axis N is 3, it will be 3. So now we have to ask sigma H, sigma V, which sigma? Sigma H is not present. If we cut it like y-axis or z-axis, we won't get an equivalent configuration. But if we cut through H, C and Cl along the principal axis, if we cut like this, these both Cl can interchange with each other. Okay, so that means it has a sigma V. So the point group will be C3V. Okay, I hope this is clear. These are simple examples that are asked in questions. For example, water. Water is also an important one. Water we have seen earlier. It has a C2 axis. Okay. So and on the along the principal axis, it has a sigma. So it has a sigma V. So it is C2V. And these are very common examples. That's why I am telling you. So if these are clear, I think you will be able to find out the point group of any other molecules given. If I give you one molecule, can you tell? I'll give you one yeast molecule, XCF. Can you tell the point group of this molecule? Imagine this as a square. Okay. So can you tell the point group of this molecule? Which principal axis it has?
C4, ma'am.
Yes, correct. Good. It has a C4 principal axis. Now, whether it has C2 axis perpendicular to the C4 axis, that is the next question. C4 axis you got along X axis, right? Now, along Y or Z axis, can you find any C2? If, for example, if I take here, hold here, and if I rotate, what will happen? This will move here and this will move here, right? So such a kind of C2 axis, can you imagine?
Yes, ma'am.
Take a notebook, like notebook is rectangle, but any object which has a like four sides equal, which looks like a square, and then like for example, if you have such a molecule, you find out C4 like this, right? That is correct. And if you rotate like this, hold C2 axis, right? Okay, so like that you have C2 axis. So if you have C2 axis like that, then the first letter will be D, right? And the principal axis here we have 4, C4. So D4 it will become, and we have perpendicular to principal axis, we have a sigma plane. So sigma H is present and the point group will be D4H. So I think this is clear. If you have any doubt regarding this, you can ask me, or else we can move on to next question. And these are some references from NPTEL site. So the basics of all these things has been explained there, because here we are just solving the questions, no? So in order to know the concept better, you can go and visit this particular classes. It will help you in order to understand more clearly how you are getting such answers. Okay. So now the next question I have taken from spinals. So these are very easy questions, spinals, because this comes for one or two marks questions. And if we know some basic concepts, we can answer the question very easily. So what is a spinal? A spinal is a class of minerals which has a formula Ab2X4. And A here is a divalent cation, B here is a trivalent cation, and X is any anionic part which can be oxygen, sulfur, chlorine, selenium, etc. Okay, so now the 2-3 things that we should know here is that whenever a crystal is formed, we have seen that since cations are smaller in size, they occupy voids and anion occupies the crystal lattices. Okay. This concept will be needed in the coming session. So for example, if in a normal spinals, we have two cation here, A2 plus and B3 plus, and X will be occupying the crystal lattice. So where A2 plus and B3 plus, in which voids it will be present, whether it will be present in tetrahedral voids or octahedral voids. Based on that, we can divide spinals into normal spinal, inverse spinal, or mixed spinal. Okay, so if A2 plus is present in tetrahedral voids and B3 plus is present in octahedral voids, then it will be normal spinal. And in inverse spinal, A2 plus will be present in octahedral voids and B3 plus will be present in half of octahedral voids and half of tetrahedral voids. We will come into the concept of mixed spinal later. So first of all, we should be thorough with these two things. What is a normal spinal? What is a inverse spinal? So how to find out which spinal is which one? Okay, so this can be done with the help of CFSE or crystal field stabilization energy. If B3 plus CFSE in octahedral is greater than A2 plus, then it will be a normal spinal. Just we have to find out the CFSE of B3 plus and A2 plus. If the CFSE of octahedral field of BFSE is greater, that means B3 plus will be present in octahedral. In which case B3 plus will be present in octahedral in normal spinal. So just this one thing you have to know, that is CFSE you have to calculate, and if CFSE of B3 plus is greater than A2 plus, it will be normal, and if it is the inverse case, that is A2 plus of CFSE of A2 plus is greater than CFSE of B3 plus, it will be an inverse spinal. And some general generalized points has been given here. If in a case, in a spinal given AB2X4, if both A2 plus and B3 plus are non-transition metal, then in that case, the spinal will be a normal spinal. And if A2 plus is a non-transition metal and B3 plus is a transition metal with these many configuration, that means except D0, D5 and D10. Except these three configuration, if any of this configuration means it will be normal spinal. So without even calculating the CFSE of A2 plus or B3 plus, you can directly find out which kind of spinal it is, and it comes in almost every year for 2 or 1 mark question. And in next case, if A2 plus is a transition metal with this many configuration, and if B3 plus is a transition metal with D0, D5 or D10 configuration, it will be an inverse spinal. And the last point is, we know this one, D3 and D8. Without even calculating, we can D3 and D8 has highest CFSE. So if any metal has D3 or D8 configuration, it will prefer octahedral voids. So if A2 plus has D3 configuration or D8 configuration, it prefers the octahedral voids, means it will be an inverse spinal. Similarly, if B3 plus have D3 or D8 configuration, that means it prefer octahedral voids. That means it will be a normal spinal. So without even calculation of CFSE, just by looking into the configuration of the cation present in a spinal, you can find out which kind of spinal is this for a particular extent. Okay. Now how to calculate CFSE? I think you all know this, but still I am just giving you an equation, simple equation. We have to just multiply minus 0.4 into number of electrons present in the T2G orbital plus 0.6 into number of electrons present in the EG orbital. And we have to take the absolute value of the CFSE that we are calculating. And then we are comparing the CFSE, which one is having more CFSE. Okay. So these are some example. MgAl2O4. MgAl2O4, in this case, the first point what we saw, if both the metal A2 plus and B3 plus are non-transition, it will be a normal spinal. So no need of any calculation. We can just directly find out that it is a normal spinal. Okay. Now we can take an example of where you need to do a calculation. Fe3O4. So Fe3O4, you can find out it is not in a AB2O4 formula, AB2X4 formula, right? So we can write it in a AB2X4 formula. A here Fe is 2 plus, and here Fe itself is in 3 plus and O4. So now we have to find out Fe2 plus CFSE and Fe3 plus CFSE. Fe2 plus is having a D6 electronic configuration and CFSE is 0.4 delta O. And Fe3 plus is having D5 electronic configuration and CFSE is 0. So that means the CFSE of Fe2 plus A2 plus is greater than B3 plus. Fe2 plus is greater than Fe3 plus. In such case, what will happen? It will be an inverse spinal. And in some cases where both the metal has same CFSE, in that case, what you will do? How you will know whether it is a normal spinal or inverse spinal? In most of the cases, that time it will be mixed spinal if both CFSE is 0. There are some exception that I will let you know through the class, but most of the cases it will be a mixed spinal. Okay. Now in the question, it is asked MgAl2O4. Okay, I will let you know the question. I will read the question once again. Oh, what is The spinal structure of MgAl2O4 has cubic close-packed arrangement of oxide ions. So oxide ions is present in the lattice. The fraction of the octahedral and tetrahedral sites occupied by cations respectively are. This is the question. Okay. So now if we check MgAl2O4, Mg and Al both are non-transition metal. When both are non-transition metal, we told the spinal will be a normal spinal. So if it is a normal spinal, then what we told? in the case of normal spinal, A2 plus occupies the tetrahedral position and B3 plus occupies the octahedral voids. Here A2 plus is Mg2 plus and Al is in Al3 plus, right? As per the formula AB2X4. Okay, so Mg will occupy the tetrahedral sites and aluminum will occupy the octahedral sites. And in any close packing, we know that if there are n number of atoms, there will be 2n number of tetrahedral voids and n number of octahedral voids. Okay, so here the lattice is made of oxygen, right? If one oxygen atom is present, that means two tetrahedral voids will be present and one octahedral voids will be present. In MgAl2O4, it is told in the question that it is cubic close packing FCC, 4 atoms per unit cell. So 4 oxygen atoms are present. If 4 oxygen atoms are present, based on this, what will be the ratio of tetrahedral and octahedral voids? If 4 oxygen atoms are present, 2n tetrahedral voids, meaning 8 tetrahedral voids, and n octahedral voids, meaning 4 octahedral voids will be present. So among the 8 tetrahedral voids in MgAl2O4, 1 Mg is present, right? So 1 Mg will be present in 8 tetrahedral voids. Therefore, the fraction of tetrahedral site occupied will be 1 by 8. Similarly, in MgAl2O4, 2 aluminium atoms are there. 2 aluminium atoms are present in 4 octahedral voids. So what will be the fraction of octahedral voids occupied? Is this clear? Do you guys have any doubt?
No, ma'am.
Okay, fine. If you have any doubt, you can ask me, okay? So, because this is a doubt clearing section. If you guys are not understanding, then there is no use of such a class itself. So, if you guys are not getting any points, you should ask. Then you can be easily do gate questions. Okay. So, this question is done. Therefore, the fraction of tetrahedral site occupied is 1 by 8 and octahedral site occupied is 1 by 2. This was the question that has been asked. Fraction of octahedral and tetrahedral site occupied. Octahedral 1 by 2 and tetrahedral 1 by 8. Therefore, the correct option is option D. And YouTube link and some classes are given here. You can go and visit there for further reference. One more question we will do of normal spinal, and I hope that you guys can answer so that I'll know that you guys are understanding what is taught here. So in this we have to find out which one is a normal spinal. So MgFe2O4. Mg is a non-transition metal. CFSE is 0. Fe3 plus, we already calculated the CFSE. D5, right? It is also 0. In such case, when both the metals have same CFSE, what we told, what kind of spinal it will be?
Mixed.
Mixed spinal, correct. Now, let us move on to the next example. This is a little tricky one. Here also, if we see Zn2 plus have D10 configuration, CFSE will be 0. Fe3 plus we already calculated here, CFSE is 0. So we assume that it will be a mixed spinal. But in this case, it is not. So this is because of the size difference. Zn2 plus is lower in size than Fe3 plus. So Zn2 plus will occupy the tetrahedral voids and Fe3 plus will occupy the octahedral voids. That means A2 plus occupying tetrahedral and B3 plus occupying octahedral. Sorry. So this is normal spiral. So this is a difference. That's why this question has been asked, because we will get confused in this case. Whenever it is true that if we do A, B, C, D, only nothing will match normal spinal according to the calculation. So we will get confused. So this is a different example, ZnFe2O4. It might get repeatedly asked also in different question paper. I have seen based questions based on ZnFe2O4. So this is a important example. So I hope that you guys take this one in mind. And we can solve the other two options also. Even though we understood that option B is the correct option, still we will solve the other option and find out whether it is what it will give and whether we are thorough with it. Okay. So in this case, option C given was COFE2O4. CO2 plus means D7. CFSE is 0.8 delta O. We can calculate, it is a simple equation, we can calculate, and Fe3 plus we already calculate, CFSE is 0. Now in this case, CFSE of A2 plus is greater than CFSE of B3 plus. In that case, what will be the spinal?
Inverse.
Inverse, correct. So this will be an inverse spinal. Only 2-3 points only you have to remember. AB2X4 will be the structure, spinal structure, and CFSE, how to calculate, that you guys already know. And what is the relation? Tetrahedral, octahedral, CFSE. Only 2-3 points you have to remember, and then you will easily get the 2 marks question you can easily answer. Similarly, option D also, CuFe2O4. Cu2 plus is D9. Anyway, even if you didn't even calculate this, by looking at this itself, you can answer this. How? Cu2 plus D9. It will have some amount of CFSE. Okay, let it be X. Okay, some amount of CFSE it has. Fe in 3 plus, we have already calculated it is 0. So no need of even calculating Cu2 plus CFSE, right? Because in this case also Cu2 plus CFSE is greater than Fe3 plus. There is no need of knowing any CFSE. They haven't asked CFSE in this case. In some questions I have seen that they are asking the difference between CFSE and all. In this question they have not asked. We just have to find out whether it is inverse or normal spinal. So in this particular question, we know Fe3 plus is 0 and Cu2 plus will have some amount of CFSE, and without even calculating, we can find out CFSE of Cu2 plus in octahedral is greater than CFSE of Fe3 plus in octahedral. So that it will also be an inverse spinal. It is same with the COFE2O4 also. In this case also Fe3 plus we know CFSE is 0 and A2 plus some CFSE will be there, and therefore it will be inverse spinal. So not even calculate, there is no need of even calculation, because calculation needs time. So by looking at this itself, if you are able to do the answer, if you are able to know that it is an inverse spinal, then you will have some extra time in your hands. So it will help you in writing GATE exam, because normally in competitive exam, the problem is everybody knows the answer, but in time limit, they are not able to answer completely. So that's why. So in such questions, you should know the trick. Just by looking at the options only, you should be able to identify that, oh, this one is 0 and so this one has certain CFSE, so it will be inverse spinal, like that. This question is clear?
Yes, ma'am.
Okay, fine. So these 4 questions I thought of sharing with you today, 2 from group theory and 2 from spinals. If you guys have any doubt regarding these questions, we can discuss. And if any other spinels or any other molecules you have doubt, you want to know the point group and all, you can mail me also. I'll look into that. Or if I know, I can answer. Mostly in group theory, the problem is you will need some material. How much ever I try to explain, it is difficult. So I will draw, or I'll find some other method. If you have some doubt regarding some molecules, specific molecules, or if it is easy, then I can tell directly by PPT I have. So using PPT, if it is easy to explain, then I can explain. Otherwise, if some specific molecules like allene, we need a cube to imagine and all, such kind of molecules is difficult. That I will prepare PPT and explain if you have some doubt regarding that. Or otherwise, other molecules you can ask now also. I'll try to explain. Or if it is clear, spinals and all, I'll definitely tell that is an easy mark. So don't miss it, and please do study that topic. No need of even studying. If you know these 2 or 3 points, whatever I told you, no need of even revising it. Just 2 or 3 points, write it in a piece of paper, and it will help you in the exam. So no need of wasting time also on that, and it is an easy mark. So I hope that you guys understood it well, and if you have doubt, you can ask me. I will check the messages also. Okay, Batman. Oh, okay, fine. So if nobody has any doubt, then we can end the session. Or if you have any doubt, then we can discuss. Okay, thank you. If it is clear, then we will leave. Okay, bye. Take care.